Okay, I'd like to do page 288, problem D8. It's a problem that looks very similar to D3 that we had done before. So watch the previous video for a discussion on that. So in D8 we want to symbolize this, this sentence, and we want to prove it. So let's start symbolizing. So something is G, so that's a existential statement. There exists X, Gx. Then no F is G. Now they gave us advice on how to do that up here, so we'll just sort of follow that advice. So for all X, Fx implies not Gx. And thirdly, we have all G are H. So that'd be for all X, Gx implies Hx. Therefore, we have the conclusion, some H is not F. So that would be an existential statement, X is H and not F. Now, this looks very similar to D3. Here's D3, and I just did. Now, what's different? Well, well, what's the same? The middle term's the same, the middle assumption's the same, and the conclusion's the same. However, the first assumption is different, and the third assumption is different. This third assumption is backwards from that one, and this one is the other function. So they are technically different arguments, although they look very similar. Hopefully the proofs are also similar. So let's go ahead and try to prove this. So make our vertical line. We have line 1, and we'll just start writing our assumptions. So line 1 is the first assumption, line 2 is the second assumption, and line 3 is the third assumption. So those are our assumptions. And our goal is to end up with an existential. Well, this goes back to just like in problem D3, we have to use existential elimination for this, and that requires us to, and I went through it in detail in the last video, so I'll just kind of start doing it here. So we take line 1 and we make a new subproof where we pick a named constant to go in for X. Named constant we'd never used before. And now our goal is to end up within this subproof the conclusion that we want. So just like before, I'm going to use universal elimination on lines 2 and 3 and replace the X with A. So I'll get F of A implies not G of A. I'll get G of A implies H of A, and that's lines 5 and 6. That's for all elimination on 2, and for all elimination on 3. Now, let's see what we can do. So we are able to get H of A out of this, right? So we can plug G of A into this and get H of A. We can also get, we will also have to use 4 and 5 somehow to get not F of A. That might be modus tollens again. So let's go ahead and get H of A first. So we get H of A. Now, where am I getting that? Well, I'm using the assumption G of A and I'm plugging it into that implication. So that's implies elimination. I cite the implication, and then I cite the left side of that implication. So in this case, line 4. So H of A, no problem. Now the real question is, how do I get not F of A? Well, if we look at the modus tollens rule, this is a rule that lets us conclude the negation of the left side of an implies. Supposing we have the negation of that appearing somewhere. Now, this again would require us, because we have a not G of A here, we need to have not G of A appearing in the proof, and so we have to prove that. As I discussed in the previous video, we don't have a rule that does the other direction of double negation. We don't have a double negation introduction. We have double negation elimination. So we will exploit these negation proofs to get what we want. And so basically copying what I had done in the past, I'm going to assume the negation of what I want. I'm going to get the contradiction. I'm going to get the double negation out of that, and then I can use modus tollens. So in this case, I again want to assume in my third level subproof not G of A. That's an assumption. I don't have to justify that. And immediately I get a contradiction, right? And that comes from, you know, this rule here, negation elimination. So it's negation elimination. I cite the negation first, so cite 8, and then I'll cite 4, because I have both G of A and not G of A. Now, what negation introduction allows me to do is, now that I have this contradiction, I can close the subproof. Look here. I can close the subproof and conclude the negation of what I had assumed. So I can conclude not G of A. And to justify that, I have to cite negation introduction. I have to cite the subproof. 8 through, here's 9 and 10, 8 through 9. Okay, so now I have not G of A, and just like in the previous video, I'm able to use modus tollens to conclude. Let me go over here. And so I am inside of still this second subproof. So on line 11, I can conclude not F of A, and that's modus tollens applied to, in this case, line 5, where the A here is F of A and the B here is not G of A. So I had to have not G of A, which is line 10, in order to conclude not A, in other words, conclude not F of A. So to cite that properly, I have to cite the implication, which in this case is line 5, and then I have to cite the negated thing that I use, so that'd be line 10. So now I have, earlier in this subproof, both, looking at where I want to go, H of A, which is line 7, and not F of A, which is line 11. So now I can AND those together, H of A and not F of A. And that's AND introduction on 7 and 11. That's line 12. Now, I'm not going to explain it in detail here because I did in the previous video, but now I'm allowed to write there exists X, H of X and not F of X. And that's existential introduction on line 12. Now, also like before, I've arrived at a sentence that's appropriate to pull out of that subproof. So I can pull that out now, and that's existential elimination. On and when I cite that, let's see, what do I cite? I cite the original existential statement and the subproof. So I have to cite line 1, and then I have to cite the subproof from 4 to 13. Now this ended up with one fewer step than the previous, so that's great. I don't know how we accomplished that, but wonderful. So there's D8. That's a mistake. I just didn't label this. So as soon as I closed the video, I noticed that thing, and then so I added it just so I concatenate this on, and it's okay.